I private chatted him.
Okay. So who spoke just now? Okay, it's no. Thank you.
It's I sent it as a downloaded notebook.
Sharp. Okay. Okay. Can I give you a chance to share your screen? Do you have it on display there? Are you working
No,
with your
no, no.
system
I'm
now?
connecting with my phone. No, I'm
Okay.
connecting with my phone. My network is bad. That's why I'm not doing it on Google Collab and chose to do it on Jupyter Notebook.
It's fine. There's no problem as long as you did it. That's very beautiful. Okay, who else? I'm supposed to see it from
I can share the notes.
you can share the note, right? Okay. You send it
Yes.
after this class. Just send it, or I'll reach out to Mr.
All
Bayomi
right.
and get it from you. So that's really beautiful. Thank you. Is there any other person? Okay. I worked on the data set, at least just for exploratory data analysis. That's just perform a few analysis on the data set. Yeah, and let's see what we have. Just a few things. Um, so and I wrote down each of these codes for the
Sir,
class.
before you continue, I noticed that there was a duplicate in the data set. So I later removed it.
Okay, duplicate. You mean in the rows? Yeah.
Yes.
Mm,
Yes.
mm. Okay, that's wonderful. Like, how many duplications did you get?
Just one.
Just one, right? Okay. That's fine. We'll check that also. Okay. So I did some analysis, just a few. I started with the smokers analysis. These were just univariate analysis. By uni, you will understand that we mean one column, just one column. You get this is office hours, so I may not spend exorbitant amount of time trying to explain this. I will just move down to um, what's it called, classification project. So we'll work on the breast cancer detection. We'll try to do something about that. So yeah, so here I decided to write a code here that classifies the smokers based on the agenda or based on their sex. So this line, let me split this up here just so you see. What you are seeing here, this line of code you see here is where I did the major task. So this variable smoker by gender is the main
Are you
thing. Every
sharing your
other
screen?
thing, yeah, just okay. Wait, you are not seeing my screen?
No, we are not.
We can't see your screen yet.
Okay. Thank you. Oh, sorry, I thought it was being shared. Let me get that. Sorry about that. Can you see it now? I believe you can see it now, right?
Yes.
Okay. Let me
Yes, sir.
increase. Yeah, let me increase the size too. I think I need to increase the size, especially for those of you using your phones to join in this call. Okay, so this is where the main thing happened in this code. This variable that was defined here, smoker by gender. So what I did here was I just classified the smokers based on the agenda. You get, so based on the agenda, the way to write it. Remember that at the top we had created our data frame before the class ended in the last class, and we assigned the data frame to DF. So every call from the data set, or from the data frame rather, will be called with the df variable. So now here, let me leave that. So you have df dot group by. So like you want to group, you just want to pick a portion of the data set and work with, and you want to group it by something. You get? So we have two particular parts of our data set. That's the sex variable and the smoker variable. That is the sex column and the smoker column. So we want to classify smokers based on their gender. So the number of smokers from the data set that are males, the number of smokers from the data set that are females, and all of that. So this was the code here. The f dot group by. The group by method is a method in pandas that you use to achieve that. And then you see this size function is to help you generate the length of that particular space that you're looking for. When you come down here, this print statement is just printed. It's just a normal print. So you just print this slash. The slash n is just telling you to give a space. That's the meaning of the slash n. So you're having smoker distribution by gender. Then smoker distribution by gender gives us this. So smokers. Let me do something at the top first, just so you don't get more confused, to explain okay, df smoker. Let's see what type of values we have there. Let us print those head. Let's see. Okay, it is a yes no column, or let's just use dot unique. So it has two categories, yes or no, yes or no. Those are the kind of things you have there. So the smoker column has yes or no, while the sex column has male or female. If you did not use this size, normally sex column is going to print out male or female. Normally, sex column would either give you a male or give you a female. We can check that also here. Do it df dot sex. That's another way of calling it dot unique, of calling a column. We can just use dot. Look at it. For the sex column, you just have female, male. You get? So the essence of this dot size method that was added to the end was just to extract the count, like the number. You get the number. How many males are these? How many females smoke? That is, you can see it here. No, that is those that this no represent those that do not smoke. So for those that do not smoke, yes, those that smoke. 115 here, 159 here. This is so we have 159 males that smoke, and 517 males that do not smoke. We have 547 females that do not smoke, and 115 females that smoke. We can check something up here before even going down to doing this. Let's see the value count for sex. I personally wrote it this way so that you understand that this is another way of calling a column. You can do it the normal way I taught us at the beginning. You write your sex. The two of them will work. So let's see it normally. Okay, so normally we can see that there are 676 males and 662 females normally. And for the smoker and this thing too, let's just copy this and change the column name to smoker. So you have smoker. So see it here. So normally there are 1064 people from the data sets that are not smoking or that do not smoke, and we have 274 normally that are smokers from in this data set. So the data set consists of more non-smokers than smokers. You get that now? So we are moving down. So look at this here. So what this table just did was to help you know the ratio of men that smoke. You get to females that smoke. This is majorly the count. There's no proportion here. There's no ratio, like what I said mistakenly. There's no ratio here. Like there's no percentage. You get we did not do any percentage. In further analysis below, you're going to see that. I don't want to stretch so much on this because I want us to build something. I'm going to share this notebook later with us. If you observe this thing that I'm writing here at title, I'm just using that to make a title there at the top so that when you are reading this notebook, you understand. Watch me if I delete this now. If I delete this thing, you see that stuff that was at the top has left. Get. So if I want to ensure that there's a title at the top that just describes it, rather than coming up here to click on text and do that, I can just write here after the comment symbol with the art. I'll just put art. Then we just write title. Before anything you want to write, you will see that it will just come automatically. It will come to the top. So that's just said. So we wanted to check smokers again by region. This time around, smokers by region, similar lines of code. The two things that we want to check, smokers and the region and how they are distributed. You get. So how many people smoke in this region? How many people do not smoke in this region? The same with the F dot group by. Then we capture the two regions. Then we just use the size and unstack. So see what we have here. For in the northeast region, 257 people normally do not smoke, while 67 people smoke. See, before you do this, look at this. Let's do region value count, df dot region dot value count. Remember what I said, it's the same thing with using the square bracket. So look at it normally so that we can have them simultaneously. Okay, watch now. Normally from the southeast, there are 364 people. Southwest, 325. Northwest, 325. Northeast, 324. What this one did was he classified them based on, the classification here was based on whether they are smokers or not. So from the southwest region that we had at the top to be 325. Here we can see how they relate to smokers here. You can see that here you are not just having that, you are having that the southwest here, there are 267 of them that smoke and 58 that do not smoke. Southeast 273 do not smoke and 91 smoke. You get. We will go down and see the proportion or the ratio. So these are just analyses, these are just insights. You get. There are certain informations you as an analyst can generate from all of these things that you're doing here. And this is something that you most likely do in Excel using your pivot table, something like that. Yes, I think sometimes you make use of pivot table for those that use Excel. So your group by helps you to achieve those same things. Meanwhile, pivot table can also be done here. But let's move on. Average body mass index by gender and smokers. So observe this line of code is a bit different. This is different from this. We wanted to calculate the average BMI, average body mass index by gender and smokers. Let's see the result, and I'll explain that here. So you can use this thing to make an hypothesis that for males, the body mass index of those that smoke, for males, you can use this to create an hypothesis that the body mass index of those that smoke are 31% or greater than 31%. I mean, greater than 31, not 31%, greater than 31. That is the body mass index of those that smoke is greater than 31 or is greater than 30. You can use that as an hypothesis. Remember, an hypothesis is something that needs to be proved. You want to check if this statement is true or not. If it is true, then we go ahead into creating maybe a law or a theory. In scientific research here, what you do most times is that you have a null hypothesis and you have your alternate hypothesis. Then you're trying to use, this is how hypotheses are actually generated. You gain certain insight. So you want to see let us even look at this thing here. For the males, it feels like those that smoke, although trust me, this data set is not representative of a good number of people that should be used if you want to generalize this particular analysis. What I mean is, in normal statistics, what you do is that there's a population that you want to deal with. You want to know the body mass index, the possible body mass index of people that smoke. You get the average. And when you want to do something like that, you would consider possibly teenagers. There are teenagers who smoke, and there are adults who smoke, or let's say young adults, and there are elderly people who smoke. So there's first of all going to be a large population, but because you cannot go to the whole population of people in the given location, you cannot call for a census. You get, maybe in that given location, you can decide on a little aspect of people that you could take that information from and then go and perform your analysis. That little portion of people that you're considering, which should be a representative of the population, is called the sample. And then you observe that after doing this thing, once you have gotten this thing, you can now formulate an hypothesis that you can now go further to prove. You get. So that's how at times you hear people talking, public speakers or some motivational speakers, say things like statistics shows that. For the ones that are actually correct with the statistics that they give, this is how most of those results come out. They just get data that relates to that thing and then give it to an analyst or a statistician or someone into machine learning or data science. Just generate some insights from this thing that you have, and that's how you keep having all of those 75% of those that this, and you hear all of those stuff. So this is how they actually happen. So from here we can see that the average body mass index for the females that do not smoke is 30.5 according to this data set. Remember, according to this data set, the average for males that do not smoke is 30. And you can even observe something. It's like those that, how this is happening is strange. Those that smoke, okay, yes, those that smoke for the females are losing. It's like they are losing weight. Although the difference is almost negligible, 29-30. And for the males, it feels like the more you smoke, the more you have body. So the smokers here have more than this, you get. But the data set may not be a full representative, you get, of what's maybe published into real time. But this is anybody that work in real time or in real life with a company to generate any of this information for an NGO or any organization that may be in need of this data. It's still the same process. So as long as the data is accurate, any result that is called upon will also be accurate here. I want to speed up a bit. So this is age distribution of smokers versus non-smokers. So the difference between them. This is just like doing your normal describe. You remember I taught us earlier that if you do df.describe, it would give you the 5 summary statistic of all the numerical variables that you have. Look at this here. See, for age, all of those stuff you get. But here, what we just did was we are making it specific to we group the data sets by smokers, which is supposed to have yes or no as the unique values. And in that, we then pick the age column. You get. So we want to get the average age of those who are smokers, the number of counts of those who are smokers and those who are not smokers, the average age of those who are smokers and those who are not smokers, the minimum age of those who are smokers and those who are not smokers, the maximum age, and all of those things. That you remember the dot describe gives you all of those things. Look at here, you have count, mean, standard deviation, minimum 25% percentile, 50%, 75%, and the maximum. So when we run this, you can see what you're having here. So you can see that the mean age of those who do not smoke, 39. The mean age of those that smoke, 38. All of these things, insights can be are always generated from this information that we have here.
Excuse me. Good morning.
Good morning. This is speaking. I'm listening to you, please.
All right. Okay. Please, I just have one question. The print that you do, are you the one that inserted all these other thing? Because the previous times when we printed, we just print the data name, the name assigned to the variable. Same
Yeah.
different things.
Okay.
Yeah.
Okay. You mean all these things here?
Yeah.
Like I can just delete them. Yes, I was the one that assigned them. I was the one. If you watch, it's it's like just creating a title at the top. But I wanted to centralize it. That was why you were saying things like, let me put this first. This is just a symbol to go to the next line, but that's not necessary. Let's see something like this again. It doesn't do anything. It's just a normal print statement. It doesn't change anything. It just put like a title at the top. Can you see it? Please, what I said, is it clear, please?
We don't have to print this way, right? Compulsory to print like this.
No, it is not. Watch. If I comment it out, you still have what you want. In fact, I think you if I remove the print statement here, you even end up having a more beautiful stuff. Let's see what this looks like. Watch. Look at what you're having. Do you understand? So just write it the way you feel is best for you. What I did was I did for one, and I was just copying and replicating the codes all through. So you observe that they are very similar. Just changing for parameters. I hope this is clear, please, for the lady that asked the question. I hope it's clear now. Okay.
Thank you.
Yes. So I'm just trying to do some analysis. Let me forge ahead. Okay, I could also remove this, so it looks like the other one is done. Okay. Let me just walk. Let me leave this and just go down a bit. Okay, some visualizations. Yeah, I was using Seaborn. I think I should let me remove this guy so that my plots will be bigger. Let me remove this subplots thing. I just wanted to have a generic high. I was trying to set it. When you perform an analysis, you generate plots, visualization. Meanwhile, this is not a very beautiful one. There are packages in Python you will use. You have a very interactive plot. Get an interactive, it's like a dashboard. Then once you start hovering around it, you'll be seeing what it is mapped to on the y-axis. You see it around something like Plotly, which we're not really going into that, but you would see that. So what this one here did, I need to do, was we created a visualization that shows the distribution of smokers by gender. So what we calculated at the top, just displaying data frames. Here we are saying we are using an image to describe it. Remember, she said that an image can even replace 1,000 words. You get, so that's what this visualization here is doing. So we can see that for the females, you can see it's just those that these are the legends or the labels to help us to interpret this thing. Those who do not smoke, females who do not smoke. For females, because this is female, for females who do not smoke, they are slightly above 100. For females that smoke, they are above 500. Because this is, oh, sorry, female, this is no, female who do not smoke. This is female who do not smoke. Females who do not smoke are above 500. Females who smoke are slightly above 100. Males who do not smoke are still not up to 200. Males that blue, sorry, yes, this, yes. So that's males that smoke slightly below 200. Males that do not smoke, almost the same with the females that we have. Get go down, remove the subplot. I need it big, that's why. Let me explain something here. I've not explained the use of seaborn. So you may be confused about how I was able to generate all of these plots. Now, just listen to me. There are two basic frameworks in Python that I use for visualization. I said basic. It does not mean that those are the only frameworks. There's matplotlib or matplotlib, as some people call it, and there's the seaborn. The seaborn was built, you get, on the of matplotlib, just the same way pandas and numpy exist together. So this SNS is the alias that we used to call seaborn. How it is called is it is at the top, but we will not need to go there. You'll see it called this way. This is how it is imported. Import seaborn as SNS. Yes. So I keep using that SNS rather than having to write seaborn. Just the same way I taught us import pandas as PD. That's the same thing here. So you're having this. Now this is we are getting the distribution of smokers by region. We are trying to create a distribution of smokers by region. So here how you do it is you call it, which type of plot do you think will describe this thing well? And that's another thing that you will need to understand. What type of plot really helps you achieve what you want to achieve? Is it a histogram? Is it a bar chart? Is it a pie chart? You get what type of plot? When you look at what you want to describe in your mind, you know this is a distribution that has to deal with count. You are counting how many people. When you are dealing with count, it is best to think of things like bar chart, count plot. This count plot is literally a bar chart. You get, so look at it here. You have SNS dots. You just call the plot that you want to use. There are different kinds of plots, plenty kind of plots. Trust me, you've not heard many of them in your life. There's the violin plot. You might have never used it and you may never have a need to use them. So like I would always say, it is the need that you want to solve that brings you, to whatsoever tool you need to use in Python. So the next thing you do is just call the name of the data as data equals to df, then what you want to be on your x axis and what you want to be on your y axis. So on our x axis, we want to have the regions, and this our hue, which you are seeing here. Hue is an argument that you use in your seaborn anytime you want to display categories from a given data set. Okay, let me change this. Let me change this hue to sex. Observe something. How many sex do we have? We have just 2 sex. Before I do that, look at what you're having here. You are seeing that this thing here is showing smoker, yes or no. If I change this thing here to sex, so we want to calculate the region by sex. A lot of things are going to change here. Remind me what to remove, so we'll put it back. So you can see by sex. So look at what we're having by sex. So in the southwest, blue represents female. This color represents male. So for the females, you can see how many they are here, and you can see how many they are for males too. The same thing. So hue is literally what you just use that to represent categories. from a given bar chart. It's like helping you to that bar chart. This bar chart would have been longer than this, and you observe this thing will just be a count of everything in the southwest. In fact, let's assume that there's no hue first of all. Please remind me that I'm moving this. Just what is going to happen. There is no hue. Look at what you would have. Just a big bar chart that just represents how many people are from your southwest, how many are from your southeast, how many are from northwest, how many are from northeast. But when you want to get that count based on certain criteria, you get based on certain other variable that also has several categories in them, you can just use the hue argument, then specify the category that you want to use. So which category did we use before? Smokers. Smoker. So it's not just give you this thing, it will give you how they are distributed. You get, so those that smoke, those that do not smoke, this is how many they are. Those that smoke, this is how many they are. Generally, what you can deduce from here generally is that in all of the regions, more people are not engaging in smoking as a habit compared to those who are smoking. You get several insights you could generate from that. The same thing is happening here. This is a box plot. Let me still remove this. This is a box plot. Literally, one of the things that is used for is to help you to deal with outliers. Outliers are values in your data sets that deviate beyond the normal. You get beyond the normal. Like there is supposed to be a particular range that you are expected to. Just imagine we want to take, let me make this a bit interactive so that you can understand what an outlier is. So we are carrying out an analysis that involves the sleeping time of people per day. We want to know the average sleeping time of people per day, and then you go to we are to meet 1,000 people. You realize that when you ask them, you observe that people will give you within the range of possibly, let's just say for those who like to hustle, you have between 4 hours and 7 or 8 hours. That's what you have. That means every day is either a person sleeping 4 hours a day, 5 hours a day, 6 hours a day, 7 hours, 8 hours, or let's say 9. Let's say you're sleeping really much, you're sleeping for 9 hours. If you now have somebody in that data set that tells you that he sleeps for 1 hour a day and he sleeps for 1 hour every day, you know that person is far, that figure that person gave you is not in the normal range that it should be in. So that figure is an outlier. Okay, in a class, I remember one of the times when I was still a teacher, we were trying to perform an experiment on statistics. I taught maths, and I needed to explain this to the GS1 students then. We were getting the height, we were using the height of pupils in class just to understand mean, median, and mode. But it was basically mean that I wanted to get. Meanwhile, all these students, the maximum age of the students in the GS1 class were 11. When we're getting their heights, I really can't remember the figures, but most of them were within a very short range that they were closely related in height. But there was this guy that was taller than me. I am the teacher, definitely. I should be taller than all the students. These are just one students. You don't expect them to be up to my height. But this guy was taller than me. Meanwhile, he was their age mate. He was 11 years old, but he was really tall. If you get that guy's height, let's say the others, let's just manipulate a very wrong feature and abstract figure rather. Each of them were like 1 meter, 1.01 meters. I'm using meters. That's a wrong thing to use to measure height. 1.01, 1.02, 1.2. You get? And then this guy came out and was about 2 meters tall. Get that particular person is an outlier because he's not necessarily in the range. When the mean is calculated, if you include that guy's height, it is going to affect a whole lot of things. That outlier, it helps us when you're performing real-time analysis, because if you are working on a data set that has a level of missing values that can be replaced, there are times when you consider using the mean, and there are times when you consider using the median. In situations where you observe that there are outliers, it is not best to use the mean, especially when you are working with numerical variables and you want to replace those missing values. It is best to now use median. So you start looking for the median, and that's how it fits into the place. So anytime you have outlier. So why I explained that was because of the box plot. When you want to know that there are outliers in something in a given data, you can use your box plot. Look at this thing here. This is what is actually showing us the this is just a summary of everything that happened in this data set. These ones that you have up here are what I refer to as the outlier, but this is supposed to be the range. From here, this is supposed to be the maximum, this is supposed to be the minimum. I think this is the mean. Then you have, I think, 25, a bit 25th percentile, 50th percentile. Okay, this is supposed to be the median, right? And then 75th percentile, and this is the highest level here. So that's what a box plot is supposed to describe. Certain insights can be generated from this. That's why we also advocate for learning theory. People want to do data science and just want to hop on and use Python. It's fine, very beautiful. But many times you need to understand some of these concepts. That some people go extra mile to learn some things. After they have gotten interest in this, you see people learn things like differential equations on their own. They didn't go to any school. They just picked up YouTube videos just to advance the knowledge, so that when they are interacting with notebooks of experts, they can relate with what they are doing. When they are reading documentations or research papers, and most of these research papers are always published with some of these mathematical terms that if you did not engage in engineering as a course and really did fine with it, the tendency that you understand it is very, very slim. Like myself, I always say I did not study engineering, I did architecture, which doesn't relate with all of this. But because I was going deeper into AI, data science, and machine learning, I had to start reading up some of those really advanced calculus-based topics, just so that I can understand all of those stuff. And that's how it should also happen with you as you move on, as you grasp the level of knowledge that you want to grasp, or that you are interested in. You may need to just advance in some of your knowledge. And trust me, some of these things will not be as hard as you feel like they used to be. Let me move on. By 10, I should wrap up all of this and we would go into the classification-based project. Okay. Here we created a heat map just to show the correlation. I don't want to bore us with this. What I'm majorly doing is explaining the lines of code. This is how you select several columns altogether. So we selected age, body mass index, children, charges. Okay, so these were the columns that we just wanted to perform a correlation between all of them. So this is, let me see if I can go down, or let me shrink it a bit so that we can see it well. I would still expand. I just want it to be visible. Okay, see. So this at this point, this value you have here is the correlation value between charges and age. This is the correlation between children and age, correlation between BMI and age, correlation between age and age is 1. And that's the same thing you have all through. So this one is between age and BMI, between age and children, between age and charges. We don't really, there are some things that we can decode from here. From your correlation matrix would always lead you into your regression plot and all of that. Let me increase this again. Okay. So we performed some further analysis. The first ones we were doing were just by variant analysis. That it wasn't just two columns, and then we decided to just go a bit. Somebody suggested this thing that I did here in the last class. I think it was Ezekiel. He said we could create another column that had the age, like the ages of the people, and splitted based on if you are between like 18 to 30, it will give you a particular age.
I said that.
Yes, exactly. So what I did here was to create that. Normally, if I wanted to explain that to us, I would have used an if statement. I would have used an if statement and the for loop, because that would be what you can interact with. But this is just a method in pandas that the dot cut method. You just pass in the column that you want to do. In fact, let me show you. Normally, if you write the f dot columns, you observe that there is no age group column. This age group that we have here is not present. Oh, the reason why this is present, you need to understand. I ran the code from the beginning to the top, so it is taking account this and this. If you go to the initial table and check it, you observe that those two additions were not there. I think you should check that. Look at the initial stuff that we have. Please, are you with me?
Yes, sir. I'm here.
Okay. I'll prepare that person to is following apart from Ezekiel. Let me check the listing. Okay. Yeah, I see you. Okay, so you would observe.
Yeah, with you.
Yeah, thank you. You would observe here that you have age, sex, BMI, children, smoker, region, and charges. Those are the stuff. Those are the tables that we have here. Yeah, those are the stuffs we have in the table here. But if you go down, you will now realize that we are having more things there. Is that place? Okay, it's control. No. Okay, look out here. We are having age group and BMI category. What we did was we just had to create another column called the age group column. You get, so that we can add. There's something that we needed to achieve. You get, so we wanted a situation whereby when we are plotting this thing, we can just have range and count of the ranges. So those who are between 18 and 30 years, we will compile all of them we will compress them into something and take account of them. Those who are within 30 and 40 years, we take account. 40 to 50, we take account. 50 to 60, we take account. 60 plus, we get 60 plus, we take another account. So, and then we now did the average age of smokers. I mean, yes, we took the age group of each of the smokers. So we grouped smokers based on their age group, and then we took the mean charges for their insurance. Remember, this is health insurance. Sorry, we didn't spend so much time having to understand the problem statement, but this is US health insurance. It was also because of time, which is wrong. You should understand the problem statement before doing anything. But I believe that we understood the idea. That was why I had to progress to this point. Okay, so the charges that were made for smokers, you get, so we divided the age group based on or we divided the smokers based on their age group, you get. So those who are smoking and those who are not smoking, the age group and the charges that they incur. You know, when you go for health insurance or all of this insurance, you most likely, there's even a tendency that you don't have any loss, you don't have any health issues, but there's a possibility that it may come up in the future. That's the reason for things like this insurance. So let's see the charges that they would incur. Let me run this Okay, I need to let me remove some of the stuff we have at the top so that we don't, because it's still showing us what we have. Is that same thing that we have in the plot that is displaying. I've created a warning package to deal with editing. So let me reduce this so it could be much visible.
Hello, sir.
Yeah, I'm with you.
All right. I noticed the classes of age that you selected from 18 to 30.
Yes.
Then the next class was from 30 to 40. Will age 30 not still feature in the second class
Okay,
from 18
it's
to
a
30?
no. It's a close bound. It would actually end at, it will end at 30. It will not capture anything 30 in the next one. You get it will take 31, 32, 33. Do you understand?
Yes, I
Yes,
understand. So,
yes, that's how it's actually happens. So this is a bar plot. It's just like the count plot. It's just like the count plot. So you can see the same thing. This is just describing them. So you can see those that are between 18 and 30. Normally, if you wanted to create a histogram of just the ages, you will see the way the thing. If you remember in the last class, we were trying to do something where I just did the F. I just did the F. After this, I would move on to the breast cancer stuff. Just did the F age, and we did the plot, and we specify the kind. Oh, sorry, there's going to be an error here. Need to put it in quotes. Plot and specify our kind thing. It should be a histogram. Let's see this. So look at what it was looking like. It will be hard to generate any insights from this. That's the essence of bivariate, multivariate analysis. If you just use this age, we were even confused as per the distribution. You get, but converting the age column into this, that is splitting it based on, let's take 18 to 30, the youngest set of persons or people rather. You get 30 to 40, 40 to 50, 50 to 60, 60 plus, 60 and above. Look at what we were able to have a better generalization self for this. You can see now, you can see here that those who are within 18 and 30 years that are smokers, that is years that are smokers, are actually more. They are more than those who are not smokers. I'm saying something here. Who is observing something? Who else is observing something? More than those who are not smokers. Okay, there's no need for that. Take my time. Excuse me, please. Okay. Yeah, so I was saying those who are smokers that are within it even seems as though the more we climb, the more we realize that from the data set, it's like the higher the ages go, we realize that there are more people who are smokers and who are
yes,
not smokers. Yeah, so it is dependent. This is dependent on how the data was actually collected. It was the collection of the data that led to this. Yes, if it was a random selection with let's say without any form of bias, that is the same number of old people were met, the same number of 18 years to 30 years people were met, the same number of 30 to 40 years people were met. It may not appear this way. It may not. Because someone can want to make a conclusion from this and say that 60 years old plus people smoke more than the younger people, your conclusion will be wrong. And that's why they always tell you that you cannot draw, you should also know this, you can't draw conclusions based on, you cannot draw conclusions based on visualization. As good as they may be, conclusions must never be taken from, you can only gain some insights. You can gain insight from your plot. It is models, graphs, those equations that they teach you in math, those models that you create, those are what you can use to draw conclusions. And you will combine your model with the knowledge of the domain that you have in order to even go ahead and say what this model has given me is the best thing, is accurate. So you don't make unnecessary mistakes that you have to regret in the long run. When you check through the notebook, I'll make sure that I do not forget. I'll share this with us so that you can just see. One of the reasons why I walked us through this is so that when you are going through the notebooks yourself, you can understand the things that were done, without the assistance of your teachers. So once you see this notebook, you know what to do. You know how to address things. You can interact with it and know, oh, this was what Mr. Ejike was doing. This was what Mr. Abayomi was doing. This is what the Nigeria Youth Drive is trying to achieve in the class there. So there was something I changed here. Okay, let's leave that. So that's about that. That's about that. I want to believe that there are no further questions with regards to this. So we spent literally 1 hour explaining this notebook. Okay. Okay. So thank you very much for attentiveness with reference to this. I would share the notebook. Let me think I've shared it before, but let me just paste it now on the chat here so that you could also, I do not want to forget about it. So let everybody have access to it. At least those who are in this chat should have access to it now. Okay, so that's the notebook we just dealt with now. So you could go through it. So we want to understand this breast cancer this problem and see if we can do anything about it. Normally, okay, please, does anybody have any question before I proceed?
Hello, sir.
Yes.
Olukemi here, sir.
Okay, Olukemi.
So my only question is, doing this analysis, sometimes I know there are times you would not be able to recall you know what you want to do, but recalling the particular formula to use might be tedious. So is it possible we can go to ChatGPT or just explain what
Yes, so yes, it is very allowed. It is very allowed. But you just need to be careful when using AI. In fact, that's what, don't believe those who tell you that AI tools will spoil you. At the same time, believe them. It's a two-sided statement. If you really want to learn fast, the truth is those who are intentional will learn faster with AI. Those who are intentional about their learning will go faster using ChatGPT and all of those stuff. In fact, back in the days when I started, what was popular was Stack Overflow. When you have any issue, you go online. The tendency that someone has had that issue before on Stack Overflow is very high. You get, but these days, if you try to start doing your Stack Overflow, in fact, people don't even use it. I doubt. I can't remember the last time I even thought of using Stack Overflow. But the only problem why I think you should be very careful is as you're learning, when you're using your AI tools, be very careful. Before you run to AI tools, try to see if you really understand what you want to do. And maybe you have run it and you have forgotten the lines of code. Then you can now describe it to your AI. And once the AI gives you the response, understand the AI's code. Don't use it blindly. It helps you improve yourself. There are people I know that have improved their coding skills like faster than normal because they started using AI tools. So they are not just cool. If you leave them without the AI tools, they still know what to do and do it very, very well. So it's advisable to use it. But first of all, understand what you want to do, then give it the right prompt. AI can also mislead you. It hallucinates based on the response that you give to it and the context of what it has been trained with. Yes. Yeah. So that's it. So for the breast cancer Wisconsin data set is we want to predict if from the tissues of the particular breast that is gotten.
Yeah, I want to ask a question.
Okay.
Yeah, regarding the you just finished explaining. Okay, now I created my hypothesis. I state my purpose of hypothesis, and I want to
Okay.
use a tools. I don't want to use something like chi-square to run the analysis. I want to use other thing. Can I still do it here?
Yes,
Or I
so
have to do it manually on my.
you see chi-square, ANOVA, MANOVA, what are those things? All those two sample tests and all of them. Every single one of them, you perform them with Python. There's a module called stats module. I don't want to go there. If you make use of stats module, you will solve any type of analysis you need. The same thing SPSS gives to you, Python will give you and give you faster than using SPSS. Once your data is arranged properly, you have prepared your data well, you get everything here. The only thing is for those of us who are researchers, you know that the standard tool for research most times, especially if it is not ML AI research, is either they are making use of eViews, SPSS, depending. There's this SEM or something like that that they use to for structural modeling and analysis. You get, so if you've gotten or if you were able to generate all your answers with Python, you must find a way to explain it in terms of as though you use SPSS. I prefer using Python. I prefer using Python. So all the times I've had to work on research till date, I always use Python to perform all of those hypothesis testing. I will always use Python. It will to perform it well and give you this thing. You are just the one to get what the tables are saying and interpret your results in the format that will be suitable for what you're presenting. Yeah, so you can do them on Python, and it's very easy too. Very easy.
Thank you.
Yeah, that's fine. Okay, so I was speaking about the breast cancer data sets. This is a basic detection, which is not what is most proposed for what you see. If you've known someone who has possibly had either a brain tumor or breast cancer and they have gone to very good hospitals, you would have possibly seen something like this. In fact, that's breast cancer detector that helps them tell if this person is having benign or malignant. Is not designed with the use of this CSV file that we want to use here. This CSV file is good, but there's an aspect of machine learning data science called computer vision. That is how the thing is actually done in real life. It's still data science, or once you can understand this one, you can move further into the bigger picture of learning computer vision. So what this one did was that they got certain dimensions of breast tissues. Let's understand the data set. Remember, we have understood what the data wants us to do. It said predict whether the cancer is benign or malignant. Medical students will know what those things speak about. When a tumor is, I know sure that one of them is telling us that the 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 cancer in the stuff is like it is like a big, like this is serious cancer, and the other one is something minute. Let us ask. We are not um
Benign just means that it doesn't harm, while malignant
okay.
is harmful.
Uh-huh.
Yeah.
Exactly. So you can just see it. Even if you don't understand, ask questions. Okay, see, like you said, benign tumors are non-cancerous and do not spread, while malignant tumors are cancerous and can invade nearby tissues and spread to body parts of the body. One of the beautiful things about data science is it makes you'd have no different fields, especially if you are working in different domains. Okay, so how this data set was created was they got pictures of particular breast cells. Pictures are computed from a digitized image of a fine needle aspirate of a breast mass. They describe characteristics of the cell nucleus present in the image. Okay, the data engineers here have really worked. So they have collected the images already from the X-ray or the scans that were done, and then they started extracting some of these pictures.
Please excuse me, sir.
Yeah, I'm with you.
Is it advisable to, as a data scientist, or to
Yeah.
to work with different domains, or just stick to one domain?
Well, people have different opinion, but in my own opinion, you can work with different domain. But there is nothing wrong with just sticking to one domain. But it's I feel it gives you more edge and chances to when you're working with different domain, and it just widens up your horizon. When I started, I really the aspect I really wanted to have this thing was finance. So I was learning all the statistics needed for those ones. You get more. Unfortunately, it didn't work out that way. But the knowledge was not wasted. In fact, if you can work, if you can work in the health sector, understanding your models and how it works, you can work in finance. You can work in any sector. Once you're a data scientist, you're a data scientist. You can work in any of the sector. Every data scientist undergoes research. So that's just the difference. If you find yourself in a new sector, in a new domain, you just make research on the things that I need to do there. That's all you get. So it's not necessarily a big deal, except you have decided that you just want to be a data scientist in this domain or in that domain. Except for that, apart from that, you are free to um you get. Okay, so we're trying to understand the data. For data privacy sake, they assigned each of these things to IDs. Okay, so they are explaining another thing. So there are several columns. We have 1, 2, and they said from 10 real 10 real valid features are computed for each cell nucleus. So we have radius, which speaks about the mean of distances from center to point on the perimeter. You have the texture, as of the particular tissue or cell. You have the perimeter, you have the area, you have the smoothness, compactness, concavity, the concave point symmetry, and fractal dimension. If you observe something about all these things here, they are all numerical values. All of them are numerical values, apart from diagnosis. Every other column that you have are numerical values. I just wanted us to understand it. Okay. They have also told us that there are no missing values. So class distribution, but let us see that. Let's download the data set and work with it. Let's download it from here. Oh, Okay, so data the CSV. Let me download it and import it. Okay. Let's create another file. Okay. Our network is wonderful. Is anyone asking a question? So let's import the data. Okay. Let's see. Okay, so let's import some the packages.
You've not pip installed them now.
You know, I said something that in Jupyter, in Google Colab, see all these pandas, NumPy, Matplotlib, and scikit-learn, they are defaultly downloaded in they are defaultly installed in Google Colab. So you don't necessarily.
Okay.
The reason why I've been doing that is because I'm taking into consideration the fact that you need to work with packages later on that are not here normally. Like, okay, I'll check something. Wait, let me check something. Let me see if there's PyTorch already. Touch. Oh, for this touch to even be there, it means it is pre-installed. You get, let's say Flask. Let me see. I'll be shocked if it's on. Wow. Most of the stuff. Really? Colab literally has all of them. Sorry, let me check something. Strange. That means when you're working on Colab, it seems like you don't necessarily need to import anything. Import Streamlit. Sorry, I need to confirm this. It will shock you that this is the first time I'm doing this. That all of them. Look at Streamlit now. Streamlit is not installed. This one will give me error. Okay, see it now. So there are some packages that by default they are already installed in Google Colab, so you will not have issues working with them.
So for Streamlit now, sorry sir for interrupting you. For Streamlit, we'll have to pip install it.
Yes, exactly. You have to pip install it. You have to pip install before you can use it. Yes, you have to. But if you are working in your local PC, you are using Jupyter Notebook in your local PC, there you would need to install most of these packages. That's scikit-learn. I think you install it. I've not worked with this thing on my local PC in a long time. That's why I do not remember any of this. I do almost all the stuff I have to do without here on this thing. I use VS Code. That's still working on local PC, but I do not use the Jupyter notebook directly itself. But this is best practices. So next thing is to get the 5 parts. So this is data here. Okay. Yeah. So let's import the data. I call it PDF. That's PD dots. Remember, it's a CSV file. So we can just pass in the file path. Remember, you don't need to call that into a string again. df.head. Okay. So we have 33 columns to work with. We have 33 columns and we have and we have, let's see how many rows we have. Let's print the shape. Okay, the shape df df.shape df.shape Okay, so we have 569. The shape is you have 569 columns. That's the meaning of that. I mean, 569 rows. Let me print 2 of them so you don't get confused. 569 rows, 33 columns. 569 rows, 33 columns. That's what we have. So let's check the column names. It'll be useful. That's why we're checking them. So do you have those columns? Okay, so we have this. This is very much. I hope there are no errors here. Okay, there are none. That's good. Now, we need to see some things before we proceed with any model building or any of those stuff. There are a few things you need to bring into considerations first. Some columns will not be necessary. Watch this df.head. If you want to build a model, look at something here. Okay, let us check their data type. General information.
So why are you not using at type 2?
Okay, the at statement, Abby. Okay, it's not so necessary. It's not very necessary. That's why I'm not using it always. But you can choose not to. You get. So I'm trying my best to be chipping in some things along the line of time, things that we should maybe take.
Okay, sir.
Or I'm just trying to chip them. That's why I was omitting some of them. Thank you. So check the general information. Let's observe something about this. This is much. So you can see that literally all the columns that we have here are float, and there is something that I'm observing here. Let's see if you are also observing that. Look at the last column. What's the last column name? What do you observe about the last column name?
Unnamed.
Unnamed, right?
Yes, sir.
Mr. Bayomi is in class. My apologies. Welcome, sir. Okay, unnamed. Now look at that unnamed column. You wrote unnamed, then you have this your
32,
column
0 null.
32 space 32. Zero null. I mean zero non-null. Zero non-null, meaning that there is a particular column that has no value in it. Look at all these ones give 569 non-null columns, meaning all the 569 columns are filled up. And if you go through all of them to the top, 569, all the columns they are filled up. All of them they are filled up. But the last one, this unnamed, or there's nothing there. It means that that column is most likely redundant. It's not necessary. We don't need it. Do you understand? We don't need that column. So the best thing to do is to remove it. So we are going to remove that column. And let's observe something else. So we are literally doing data quality check. Maybe I should write that at the top. You know what? Let me bring this guy down. So let's call this one. Okay, fine. Data quality. Data quality check. So let that be the listing of everything before the coming set of cells will be running. That's what we're going to be doing. Okay. So we have the type of the data types we have here. You can see it from here. We have float 64, 31 columns. 31 columns are floating point. One column is an integer, and another column is an object. Let's just call it is a categorical variable. Let's see it now. The integer is this ID, and we have this diagnosis too. Observe something about this diagnosis column. Let's see what it is. ID is just mapping each of the records of tissues that each person's breast tissue properties. You get that column may not be necessary, but before we drop it, let us see. There's something called municipality. Municipality is the number of is the cardinality of elements in a given column. You get, there are times when if the municipality is too high, it may mean that that column is not necessary. Not in every cases, but in some cases, like in this case here. So let me just say municipality. That's the cardinality of unique values in a data in a column, a data set of each unique value. If you do the F of let's just pick this one. Okay, so let's do dot n unique. That have to get me right. You see 539. What that 539 is telling that there are 539 unique values there. But if you go to the table and check what those unique values are, you see that they are necessary things. They are literally telling you, okay, look at radius mean. It's telling you that, okay, for this one, the mean radius is 17.99. For this one, it's 20.57. For this, 19.69. For this, 11.42. It just keeps giving you all of those details. So that is not a column that you have to do away with. There are columns those stuffs you have, they are not necessary at all. Let's use that ID column. How is the ID even written? Let me just copy the ID. Let's copy it from here. No, not from here. Let's copy this one. ID. 569. And if you look at the values that you're having there, let's just do the F ID. Let's just do dot head. They are just like, there's a name they call this stuff, identifiers. Yes, identifier. You get, so if they call you 842302, you get, that is speaking about that is like your ID number. So that column is not necessary. You get, so there are two columns now that we can see that we may need to drop. So we will need to drop, in order for us to continue with our analysis and model building, we need to drop two columns. So we will drop the ID column, ID, and remember the other one we are dropping this unnamed 32.
Unnamed.
Yes. Unnamed. In fact, you need to be very careful when you are doing all of these things. Make sure that you use, let me use the F those columns. I need to see them well and copy them well. And see it here. So let's be sure that I'm not making mistake. At times, a trailing space will just make you have an error there. So I need to convert that name where I think it's correct. Sharp. So we're going to drop them. So let us just do drop columns. Drop columns. The columns that we're going to drop are IG.
Why are you dropping the ID column?
Okay, the ID column is not necessary. From what I try to explain, you can see that the ID column is not necessarily a value that we can use in making predictions. It's just an identifier. It's just helping you to know. It's just like having names like Chukuma. This is the record of Chukuma. This is the record of Amadi. This is the record of Shubomi. You get, you keep having names. Shegun. This you get.
Can
So
you scroll up there, please?
okay, sorry. Let's go to the table itself.
Okay.
What you get, this ID is like an identifier. We may not need it. We don't necessarily need that column here. Do you understand now?
Yeah,
You
yeah,
get,
that's
it will not help in any building,
That's true.
in anything we want to do. Yeah, it's just for the record of knowing that this thing, this old record here is for this person. This old record here, this is the identifier that helps us to know that this is for this person. This gets and on and on and on and on. So it's not necessary. That's why we are dropping it.
It's a unique ID.
What did you say? Please speak up.
I think it is a unique ID for.
Yes. It's a unique ID. Yes, it's a unique ID. So the other one we are dropping is this unnamed 32. We are dropping out because it does not have any there's no value in it. The whole column is empty. And so that was maybe an error in computation by the person that collated the data. Mistakenly included that while he was copying it. So it's shown here as a column. Or maybe something was there and they deleted it, but the system still picks that column or something. That's why you're having it there. Okay. So we'll create our data frame. So we are creating the data frame. How you drop it, drop Abi. Then you have columns, equals to drop column, drop calls. Then we have an axis. What axis are we to use here? Who remembers? When you are dropping columns, what is the axis that you put? Let's respond fast.
One.
What did you say? 1. Thank you. 1. Thank you. So let us see what we have first. We don't see everything. Let us see the head if it comes out. Okay, now observe this thing that we're having. There's no more ID. starts with diagnosis. You get, and all of this. You get. So that means, does this code we wrote here now, does it mean that we have dropped our ID and unnamed this thing column? Please answer me, please. I need that answer. Does it mean that we have dropped it now? Please, I need our response to be. It will help me to flow well. With this code, does it mean that we have dropped the ID column and the unnamed 32? Does it mean we've dropped them?
No, we need to
No.
add.
We need to add what?
After the axis, there's something that's supposed to add to it.
You said what? You said there's something that I'm supposed to add, Abby. You said there's something that I'm supposed to add, right? To make it
Axis equals to 1.
axis equals to 1 is already there. Wait, let me show you something. When after writing this stuff, if you look at this thing that you have here, you observe that ID is no longer there. ID is not there. At the same time, there is
We have not given it a name. We have
Thank
not
you very
named it.
Thank you very, very much. So that's it. You need to assign it. There are two ways. It's either you assign it. If I watch, you see that let's now call df this thing. So from hence, anytime you call df, it will be making reference to this one, the next coming cells. If you call df as a data frame, it is not going to call the initial df, the initial data frame that was created, to call this one. You get. Now the reason is because this is the nearest definition of that variable to whatever cells that you have. So it's better to still call it df because it's still data frame that we want. So now if you come now and do the f dot column, see, watch. If I didn't do that thing, if I come down and do the f dot columns, it will still capture ID and the other one. Did you observe? ID is still there, and that other guy that we dropped is still there. In order not to have that, we assign the df equals to this. Now, if we do this here, you can see its ID is no more there, and the other guy at the end is no more there. If you calculate the length, you will see that to reduce to, instead of 33, to reduce to should be 31 now. Let's calculate the length. Length of what's an axis? What's that? Coming. It shouldn't give us an error now. Okay, let's just run. Let's run off because of still reading that stuff at the beginning. That's why you can see it now. Even if I remove this list, it's still going to work. So now we have 31 columns. Now let's see if there's any other thing we may need to do. Okay, now we have checked and it feels like our data set is cool. There's no error. We don't want to start checking for outliers, inliers, and all of those stuff. They may not be necessary here now. We just want to build our model and see how. For this problem, is it a regression problem or a classification problem? We have to check for. Please, I can't hear you very well, please. I can't hear you well. I did not get your question well. Your network is breaking.
I was asked to check for duplicate.
Okay. Sharp. That's good. So let's see. Let's check for duplicates. Let's check for duplicates also here. You said we should check for duplicates, right? To check for duplicates. So the
Yes.
argument will be duplicated. I think so. Oh, it even got stuff for me. So let's see. It should give us the columns. Okay. From this, we can see that. Okay. In fact, let's make the code more. Let's just do shape. Okay. Can you see that there are no columns that have any duplicates in them? So there are no duplicates. Do you understand? There are no duplicates. Meanwhile, we need to get what he said. Checking for duplicates is one of the things you always deal with when you are cleaning your data set. Check if there are duplicates, you check if there are outliers. Yes, it depending on several factors. At times, those are even the things that helps you to engineer your features before, I mean, after training your model and discovering that some things still need to be done to the model or with the model. Well, I've spent beyond my time. But it's fine. Let's see what we can do. We should still do some more. I was asking a question, please. Let's proceed. This problem that we are solving, is it classification or regression?
It's classification because we only have two
Classification, right?
categories. Yes,
Yeah.
either benign or malignant.
Thank you. It is benign or malignant. So it is a classification-based problem. Thank you. Okay, so
So please, how do we identify if it is regression or classification?
okay. Two classes ago, we learned about that. First of all, there are three types of machine learning: supervised machine learning, unsupervised learning, and reinforcement learning. We are dealing with only supervised learning in this series. And under supervised learning, we are dealing with, we have dealt with regression tasks. We are dealing with classification. I said how you know classification is that from the name classification, what you want to predict, the column that you want to predict, you realize that it will not have continuous values. It will have something like this or that. You get this in the column. You will be having categories in the column, like male, female, any column like male, any column like gender. Under gender, there are just two genders. You're either male or female. If you're asked to do any prediction that relates to that male, to that gender column, any prediction you are going to do to predict gender, that is going to be classification, because you are the prediction is not going to give you values like 2000, 3000. It will give you male or female or others, depending if the data set has things like male, female, or others. You get, if you are working with a data set that, let's say you are working on a bankruptcy data set, and in the bankruptcy data set, you realize that you are dealing with things like either the bank would go bankrupt or not. Let me assume it is a bank. You get, either the bank will go bankrupt or not. That's the column that you want to predict. If you realize that the things in the column are yes or no, 1 or 0, that is telling us bankrupt, not bankrupt. That's classification. So classification just deals, you observe that the target, the variable that you want to predict, will have categories. It will not be like things like age, where you are having things like 16 years, 20, 19, or cost, where you'll be having 16,000, 17.5. I don't know if this explained it to you well. Is I need fast response so I can speed up.
Yeah, you are correct. I mean, we understand you.
Okay, thank you.
I have another question. You mentioned something about outliers the other time. So if we have outliers, we can't remove them. But and you said we should not do the mean. We should do median or something. So I didn't get that.
Yes, okay. Okay. Trying to speed up. Anytime you are working with a data set and you want to deal with outliers, I'm not going to do that here of time. But when you are dealing with outliers, when you realize that a particular column has outliers and you want to address the, let's say, missing values in that data set, if you want to balance up, it is best to make use of median rather than using mean, especially with a numerical column. If there was a data set where we could test that, I would have maybe tried to explain that here. We can read up on that too. You get, when you are dealing with columns in data, columns that have when dealing with columns that have but let us even ask the question here on Google. You would see. I I prefer to explain it myself, but for when dealing with columns in a data set that has outliers, which is best to make use of, mean or median? Although it still depends on some of the scenarios. Okay, I've explained if there was time. I would have explained the concept of the skewness and kurtosis. Since when dealing with outliers in a data set, the median is generally preferred over the mean. Do you understand? The median is less affected, yes, by the extreme values. It is less affected by the extreme values and provides a more accurate representation of the central tendency. Statistics generally deals with measures of tendencies, either spread or centralization, as mean, median, mode, and then you see all those measures of spread. But we really do not want to go into statistical modeling for lack of time. So it is most preferred that we let's just for now, you get. But anytime you are working with a data set that has outliers and you observe that there are some missing values and you want to address it, it is best. Yes, it is it is best to replace them most times with the median. While in other general cases, it's just best to use your mean. Just replace the missing values with the mean. You can get the mean of that distance, just fill it up with the mean. We are not having any missing value in this data set. I would have done some of those imputations here. I would have done them. Yeah. Okay. Thank you.
Thank you. Thank you.
Yeah, that's fine. That's fine. I remember, like I always said, it is very good that you're curious. Yet, whenever all those things come to mind, just ask Google, or if you have a mentor, someone you could walk up to ask. Just it helps widen the knowledge and just read. Okay, so let us check the target variable. Target variable. So let's just do something to check about target variable. What's the name of our target variable? Like, what is that variable that I want to predict? What is the column name that we want to predict? What's the name of the column that we're trying to predict? Who can get that? What do you think is the name of that column? Look at all
Sorry,
the
please, I
columns.
didn't get the question.
Okay, you know when you are working on this prediction, you have your features and your target. Your target is the one that you want to predict. Why your features are the training, the stuff you will feed into the data. That is the x,
Yes,
the
your
x
X.
value. So which one is supposed to be that y? So from all these columns here, what is our y? What is our y?
Why
Diagnosis.
we do diagnosis?
Diagnosis. Thank you. Do we all agree with him that our y is diagnosis?
Yes.
Oh, thank you. That is very correct. Diagnosis. So that's what we want to check, that diagnosis column. Diagnosis. So let's check the column. First of all, let me just print head and see. That's not really what I want to do. Okay, M. So it's saying M. So possibly we have things like M and B. So let's do unique, so that we will know the unique values that we have. Let's check for the unique. You see M and B. M represents malignant, B represents benign. Get, remember what we browsed about before that? I think malignant means that the
It's harmful
malignant
and can spread.
it is harmful and can spread, and benign means it is not harmful. You get, and cannot spread. In fact, let me print that out here, because I may forget it's not very good biology student. Malignant. Okay, is harmful. There's a reason why I'm writing this, because we have to remember when we are building models, they don't understand letters, all these M and B strings. We have to convert those values into something like 1 and 0, 0 and 1, 1 and 2. So we need to know the one who give the term 0 and the one who give the term 1. Malignant is harmful.
It's harmful and can spread. It's cancerous. Oh, we should use it cancerous, right? I think that would be
okay.
better.
Yes. Thank you.
Cancerous.
Cancerous. Yeah. Thank you very much.
And can spread. We can use that.
Acneros. Cancerous. Let's just say while benign is not cancerous. So that means anybody that has has cancer. Let me represent that one with 1. Anybody that has B does not have cancer, represent that with 0. When it is time, you understand what I just did. I just printed that one out so that we will know. Let me print this one too. Anytime you put a print statement last before any other thing, there's not any print statement, it will overwrite the other ones. So you have to put print in two of them. Okay, so you have print here. Sharp. Okay, so now let's see the. Remember I said this is another way of calling a color plot. So what did you say?
No, we want to check for the X features now.
Okay, now we are still trying to understand that same target variable. But let me write it up here. At title. So we are still checking the target feature here. So let us here we are checking for the value count. So count of the unique values in the column. This is 11 o'clock. I'll be done by 11:30. So let's see that. Okay, so those that are benign, 357, and the malignant 212. The percentage is not a bad one. It's not a bad one. Okay, let us do it in percentage. What do I do inside here to convert to percent to proportion? I do normalize, right?
Normalize, yes.
Equals to true. So let's convert it. Sharp. Okay, maybe let me round it up.
Times 100.
What do you say? Okay, times 100 Abi. Wait, let me see something first. 3, if this works. Sharp. Okay, so let's do it times 100 percentage. That's times 100 to make it percent. Okay, so 62.7%. They are malignant. I mean, are benign. Why 37.3% are malignant? Okay, so we can also create a plot for this. Let's see it via a plot. So let's do the same thing. So we create a visualization. A visualization. Okay. We have df dot diagnosis dot. In fact, let me copy this whole thing this way. See, I'm going to plot it. Control. Okay. Can I do this? Okay, well, let's see. Come in. Say kind. Let's use bar. I want to see this is going to work. Oh, it worked. Okay. Okay. So it represented it here in percent. Get. If I encoded this thing in just the same way we wrote it before, let's put another stuff in front of it and see if this is going to work. Well, I think this would be a challenge, except we end up making that an argument. Is it going to work? Oh, it still did work. So, okay, so what I did was I used the same way it was here at the top. I used that. We just created at the top. We had a data frame for it. Here we are having a
Visualization.
a visualization for it, so we can see and know that. So this is what we have. So this is not necessarily it's not balanced, but it's still very okay. Let's see. The percentage is 62% to 37%.
Yes.
I didn't get you, sorry.
No, I wasn't speaking, sir. I was just saying it matches the proportion we got the visualization. If you look at it carefully.
Okay. Yes. And even if because when you are working on classification models, I hope we all are listening. I'm only hearing Ezekiel, and at times it may be I may be convinced to believe that it's the only one in class. I really want to be sure every other there's this other two ladies who look at me and I've been hearing, but I really want to be sure that everybody is following, so I don't teach the fowls of the air, like I would always say. So please, I beg you, once I ask a question, I need us to respond, please. Okay. Thank you. When you're working with classification data, it is necessary to note that that's category, that's classification data you are working on, especially for the binary classification. It is good to have a balanced data set before you work on it, before you work with it, rather. What I mean is that if your data set is poorly represents one side than it does for the other, your results will be filled up with bias. And in the long run, you'll be able to make predictions, but your predictions will not be able to be used in real time, in real life. Because any result that comes out of your prediction is going to be most likely wrong. It will favor the one that was trained with it more. Here's what I mean. If you look at this data, this stuff we just checked here, benign represented with B has more representation in this data set than malignant. And I'm sure that wherever they got this data set from, there was no bias in the selection. It was just that coincidentally, people had benign experiences more than malignant. Perhaps if they had gone to another location, to maybe a breast cancer research lab, and they had checked it, maybe most of the people they might have had maybe more of malignant than benign. So what I'm trying to say is that if you go ahead to build your models, training it with more benign than malignant, there is a chance that you may not have a machine learning system that predicts things well. The prediction will be biased because it is trained with more, it understands more benign features than malignant. So most times, what is done is that we do what is called resampling. The resampling is a technique whereby you either downsize the majority class, or you upsize the minority class to meet up with the majority class. Here's what I mean. Malignant is about 60 something percent. It is more than, benign is 60 something percent, which is more than malignant. So sometimes in machine learning, what we do is we would write some lines of code that will help us simulate more data for, it helps us simulate more data or synthesize more data for malignant so that they will now be the same in proportion. Or we will reduce the size of this one to make it the same with this one, so that when the data set is trained, when the model is trained, it has equal understanding of the two of them. Those ones too, they have their own downsides or their disadvantages, you get. So at times, when building a base model, it is best that you just build it without considering all of that. Like in this case, I think 62 to 30 something is not so bad, because 32 is above 60, is above half of 62. Let's confirm that. I hope I'm not saying wrong. Okay, 37 is above the half of 62. Yeah, you get. So let's act as if there's no problem with this. Like this is an unbalanced set, but let's take it that way. So the next thing we are going to do now is
Hello,
to,
sir.
since we have observed that this may not necessarily, we are taking it as this is not a problem. So we are going to go into.
Hello, sir.
Okay, yes, please, I'm with you.
Yeah, Ezekiel speaking. I am interested in this part, very interested, because from your explanation, I am deducing that a modeled machine will assume that, let's assume we have patients coming into the lab and we want to test for breast cancer. Our modeled machine will most likely assume more benign patients. Are we saying that there will be a dysfunction in the machine analysis in checking for benign patients and malignant patients? Is that what we are assuming here? That is, if in any scenario our data is, let's say we have benign patient, for instance, to be 80 something, and then malignant patients are less than 15 of the proportion. And if we leave our data like that and model the machine that way, we most likely will be having the machine giving us false information, right, of patients. Is that what you are trying to say?
Yes, exactly. Yes. So in fact, those are the kind of systems that leads to the death of some people. And you see, as machine engineers, that's why we must learn to be very careful with our model creation. People often say that model creation is the simplest part. Most times it feels true, and it is true in the workflow. It's simple until you start engaging in real life things. You now realize that it is actually a problem what you did. That's why that aspect called fine-tuning, hyperparameter tuning, is very essential. Now, this was a case, although it was a TV show I watched. A man went to, he started coughing out blood. And so one of the days he went to a pharmacy. Now, a machine learning engineer might have made that mistake if the system that generated that stuff was a machine learning system, not a traditional based what is it called? Is it diagnosis? Yes, not a traditional based diagnosis or dialysis was actually done. Now, this is what happened. The man was coughing out blood at some point in time, and so he went to the pharmacist, and they said that they will run. He went to a chemist. The chemist man said that they are going to run a test on him. So the man took some of his samples, feces, blood, and urine also, and then they took it to a lab somewhere and they ran the sample. The med lab scientists ran did what they needed to do, and they came back and told the man that the man had HIV. And when the man heard that, his whole countenance went down. But the man resorted into thinking and many stuff because he was wondering. He was not a pervert in terms of morality. He was not doing stuff. He was cautious. His hair, the way he barbed, he knew everything was intact. He gets at some point he began to blame his wife. Most likely his wife was going out doing extra work outside and coming to deceive him in the house, and so he must have contacted it from his wife. And then after about 2 months, this man, like they brought another result apologizing that it was a fake result, that it was a wrong result that was printed out for him. Meanwhile, on the day of the printing, the man had gone to commit suicide because he was tired of life. If he had labored that way and then he's realizing that he's having this thing at the end. Yeah, so, and when the biologists were being queried regarding what had happened, although this part I am the one adding it, this is not the movie. I'm bringing this as a machine learning engineer. Let's assume it was a machine learning student like you and I who had trained an algorithm to predict if someone is having HIV or not based on blood samples that you got. And it was, let's say it was fed with more HIV positive patients, because that's a classification problem. It was fed with more HIV positive patients than HIV negative. So it learned more about the HIV positive than the HIV negative. So most likely, anytime you see samples of that stuff, it will always predict positive, positive, positive. And because blindly we used to trust models, you would print it out and say, especially Nigerians, you hear things like, no be me talk am, na computer talk am. Meanwhile, the computer was trained wrongly. You get?
Yeah, exactly.
So in such a situation like that, this is still garbage in, garbage out. You have to be honest. The whole AI you are hearing about is still garbage in, garbage out. It is what you feed into it. It is what it is trained with, that it will respond with in the long run. You get? So that was the case. Eventually, the man killed himself, and then his children found out that the result was wrong. Why? Possibly because a machine learning model gave a wrong result because it was trained falsely. So that's why many times we used to undergo processes like downsampling or oversampling. Those ones to have their own side effect. As you journey, you would realize the reasons. But in fact, you see this one now. One of the reasons why I can go ahead without having to oversample this or to downsample this one is because the ratio is not bad. The situation whereby there are about 80% of this, and then there are just 20% of this. No, any prediction you make training this model just that way is going to be biased. It's going to predict more anytime. Meanwhile, it was later found out that the man just had, like, I think it was a respiratory issue that was minute that could have been solved. That was why he was coughing. Yes, the team predicted HIV, and then predicted that it was positive. The person killed himself. So that's how, at times, it's not only the doctors that kill people. The machine learning engineer also kills people too. So it's not every time you go and blame the doctor that gave the wrong listing. At times, the AI that you have trained was the cause of that sudden death. So you have to be careful. I hope this story really explains it well to you, sir.
Exactly. Thank you so much. Which means our machines can lie to us. We just have to be very careful. Thank you. I understand.
Yes, so, yeah. Thank you. Okay, so let's just do something we did in the last class. This B and M, I want to move fast. So let's convert it to
convert them to numbers, right?
Thank you very much. Thank you. Let me do what I did in the previous class. Let's create a map. Since that's the only thing we'll be converting, let's just call it map. No need for diagnosis map. Then we create a dictionary. All of these things can be done with something called one hot encoding, but I wouldn't do that. Anytime you see B means that that is benign, meaning that it is not really there, it is not cancerous. So we'll call that 0. And anytime you see M, so capital letter M rather, it means it is present. 1. Okay, another thing that you can observe from this plot here is that for every, let's use the value count. For every 100% of persons that come to take for the test, breast cancer test in the lab, 37% always test positive. That is 37% have breast cancer. Why 62%? Yeah, that means most of the people are not having breast cancer. That's another insight. I just have to say that, by the way. Okay, let's continue what we're doing. We'll create this map. You have dots, replace, and you can pass in the map into it. Let's see this dot head. Diagnosis dot head. So you can see now. Yes, please.
Yes.
What did you say?
So for a data to be collected and then
Who's speaking,
used
please?
for
Who's speaking,
this
please?
is only chemistry.
Okay, okay.
Yes, I believe for data to be collected and be used for machine learning models, it has to be a wide range data. It shouldn't be a data that is collected in a closed, how would I call it? Do you understand?
Yes. I understand.
So it means it's actually representing what's really happening.
Yes. Yeah.
So now, from all that you explained, is it that whenever we have a ratio that is so outrageous, we can't use that data for machine learning so that it will not wrongly predict?
Okay. There is something called synthetic data. Synthetic data. There's a concept in deep learning called GANs. I won't go there. Generative Adversarial Network or so. Yeah. So there's a concept called synthetic data that you can synthesize data. But I learned about this first, I think, some years ago. Then I had not even done anything on deep learning, but because I was doing analysis for students who tell me their supervisor said they want 800 samples, but they only have 50. Imagine the ratio between 800 and 50. That's really, really large. That's like you only have about maybe 4% of what you are looking for, because you have to calculate 50 16 times. I mean, yes, 16 times before you can get 800. Now, or maybe I'm wrong with what I just calculated. So in such situation, and they have this to submit in a short while. So start thinking of what could be done. Now there are models already existing. There are pre-trained models that can help you to look at the data that you have and manipulate the data in such a way that it will create those kind of patterns in more 750 data sets. It will look like those other ones, and it will represent the same ratio that those 50 were representing, such that you are now having your 800 data sets. So in this scenario where you brought up, in fact, in real life, most times you will not always have a very accurate data. That's why one of your work as a data scientist is to really learn how to engineer the data to the point where it is good for use. Many times you may need to read the domain of where you're working on and understand other certain concepts in that domain that may need to be applied, which will now help in whatsoever thing that you need to do. Hence, you get sometimes you may need to generate synthetic data. I've done it severally, but that's majorly for students project. When I'm working on real life work, you don't do synthetic data blindly. You don't generate synthetic data blindly. Yes, you still do that. When you go into things like computer vision, you will learn what is called data augmentation. So things like that are also done. As you progress, you would see the particular things that can be done. But trust me, most times the data comes out messed up. They will give you what they have. The client will give you what he has. So when you go through it, after going through it, if there are things that you can do to make the data come up to the level that can help the client achieve what he wants, you do it. If there are still things that are needed, you get back to the client and explain to the client these things are still necessary. They are not found yet in this data set. And if they are not here, we cannot work. Can you provide such? Do you understand? Do you understand? I hope that's clear. Yeah. And that is why it is best that the whole, from the data collection process, the data scientist is thoroughly involved in the data collection process. Thoroughly, except for these ones we used to do where we just go online and get data and do what we want to do, you get. But if you are doing real life stuff, most times you'll be involved in data collection process, at least to know what you want to do and do it the way it's supposed to be done. Data collection has almost insignificant as we make it feel. It's very necessary. Very, very necessary. Very necessary. Thank you. Way beyond for today's class. So let me remove this dot head for it. So what I've just done is I have recreated the diagnosis column. Let us do the f dot head now. You see that the diagnosis column, unlike the way it was appearing before, I would have imported warnings. Okay. You can see where's the diagnosis column, sir? I think it's somewhere here. You see it now. You can see what it's showing. Rather than showing MB, and all of those stuff. So if I go and do a plot now, let me copy this same plot I did at the top. You see this plot? You will see 1 and 0 instead of M and B. Let's do that same plot down here. Rather than this one, let's replace this dot head with it. See what you're going to have. No more M and B. You're having 0 and 1. You get 0 for benign, 1 for malignant. So that's what you have. So this enter, you hear me say majority class, please. In case I use that statement, majority class is talking about the one that has more. Minority class. But if I say the one that's positive and negative, you get positive means the one that does not have. I mean the one that has. You get the one that has the cancer. So that is malignant. But I'll be careful with my terms as we proceed. Okay. So this is just up to this point. Now let's just go straight to our splitting. So split the data. Iterate. Split the data. Okay, split the data vertically and horizontally and vertically. Okay, vertically and horizontally. Okay, vertically. Let's split it. So now this is where we now start remembering that we have not imported anything like scikit-learn. Let me just do it straight from here. We'll take them back to the top later. So from sklearn, you remember, okay, sorry, we ought to split it vertically first. So split vertically. So split, I mean, yes, vertically. That's generating our features and our targets. So our features, who can remind me how we get our features? Our features are every column except which column? Features are every column except which column?
Except the one, except the targets.
Thank you, except the target. So every column except our targets are features. So I'll say features. Thank you. That's except diagnosis. So I'll do df dot drop. So I will drop diagnosis. And remember, when you are dropping, you specify the axis equal to 1. So that's my features. Let me make things faster. So I'll say x equals to features. So I will replace that x with features. So the next one now is to our target. Our target is just that diagnosis column, right?
Yes.
Yeah. Thank you. So I can just say let my y now be the target. So now I've assigned it to it. So yeah. So now that I have this, I have my features, I have my targets. So I've done the vertical splitting. So let me split it horizontally. So I can split horizontally. So that will give me training set and testing set. Remember, you need to first of all import the module from sklearn dot model selection. I would import train test split. Import train test split. So now let's see train test split. Remember, the first thing you call is your x, then your y, then your test size. Let's just select 2%. Then your random. Okay, you see another thing here, 42. Let's assign it to, you are going to have 14. You are going to have x train, x test, y train, y test. So we just created the data just to verify and do x train dot shape. X test dot shape. Y train dot shape just to verify. Y test dot shape. You can see it now. So you have you have splitted your data horizontally and vertically. Try to round up in the next 5 minutes. Okay, so when you're done with this now, you can start thinking of the model to make use of. So we specify and let's the algorithms to make use of. When you are working with on a basic level, when you are working with regression tasks, you use linear regression. When you are working with classification tasks, you make use of logistic regression. I will say that again. For regression tasks, you use linear regression. On a basic level, fundamentally, you get foundationally, you use linear regression for regression tasks. You use logistic regression for classification tasks. Yeah, so let me do that here. So we'll use logistic regression from I think the name model should be import logistic logistic regression. We'll take this thing up later. So that's the model I want to use. So for here, we'll use logistic regression. Logistic regression. Now, logistic regression here, we'll have for logistic regression here, the next thing you do is to just, let me call it logit. That's the model name. Or let me just call it model, since you're not going to possibly use any model. Okay. Model log. Anything you want to call it, nobody's going to flog you for whatever name, logistic regression. Call it this way. Put it in. So we have selected logistic regression model, and that's what we are going to use. The next thing you are doing here is next thing you're going to do here is going to be to train the model. Train the model. So you can now, that's dots, this is the dot fit method. Sorry, it seems as though I'm trying to be fast. So we have to train the model. We call the model name model logreg dot fit. So what are the parameters I pass into the fit method? What are the parameters I pass into the fit method? Who remembers? Remember, now you are training. I used to say something about, now you want to build a model. We've selected our algorithm. We want to convert it into a model. So what am I going to pass into that fit method? You should remember. I said something about the difference between algorithms, machine learning algorithms, and machine learning models. That will help you in knowing what to do here. Try. You make a mistake, I'll correct you. Yes. Okay. Nobody's talking if you understand it. So you pass in your training set, like your X train and your Y train. That's what you pass in. I know you must have possibly forgotten it. You're passing the data that you want to use to train it, to train the model. You get, so we want to train it. We want to train it with.
You didn't hear me. I said X train and Y train.
Sorry, what did you say? What did you say? Please come again.
I said I responded, but you didn't hear me.
Okay. You said what, please? Okay. It was what I did that you said, right?
Yes.
Okay.
Exactly.
Okay. You see, I saw a question that was posted regarding random states. I think I had said this in the last class. That's why I did not very long here while writing that line of code. Random states is what is literally a value that we give such that when another person is interacting with your code, because this is a random selection, like we are selecting 20% for your test set and 80% for your training set. Because we are doing that selection, we are not literally selecting the first 80% for your training and the next 80% for your 20. We are doing a randomized selection, selecting from anywhere, anyhow you want to select. So in order for us to have similar input in our training set and our test set, a random state is chosen such that if you run this code on your own end and we check the values that I have for my X train and Y train and X test and Y test, and the ones you have, they will be the same. Though they were randomly selected, it was like the same random, it was like there was an automated system that did the random selection for me, and that same automated system did the same random selection for any other person running those same lines of code. So we all have the same thing in the long run. So that 42, if you change your random state to 0 or something else, let's say 100, you can put anything. You can even write 1 as a random state. You can write 2. You get, the difference is that you have different data in the train and the test sets. You get, but if we need to have the same values, anything that you saw here, just put it. Meanwhile, there's no default this thing. You can put anything you want to put, but generally people just use 42, and so everybody have adapted that usage of 42. You get, so it is not necessarily a you must use 42, but if you check most code base, you always see 42 being used. So thank you for that question, sir. So that has been addressed. I'll wrap up. So next. So now we are training our model. So let's do this. So we have trained the logistic regression model. When you are done training this, we want to make a prediction. That should be the next thing. Widespread. Widespread. So who can remind me what to do here? I want to make my prediction. Yeah, what do I do? What are the lines of code that I'm supposed to write? Yes. I know what we can write to, but I want us to tell me what is the line of code, and once I write that in there, I will have my prediction. I am still waiting. Think and go back if you need to go back to something. I need a response. To go no further from here.
Equal to y test and y train.
Say that again, sir. Don't be scared. If you're wrong, the higher you can do to flog it.
Y squared equals to y test and y train.
And y 10? I don't understand. Y test and y 10.
Y train, not test.
Okay. What do we say about that? What do you say about what you said now? Well, that was a really nice one. That was a nice one, but that's not correct. In fact, you tried really well, but that's not exactly what you need to do. Let me wait to get another response. Who spoke now? Who gave that suggestion now? Why are people scared of speaking?
Jerry, sorry.
Oh, Jerry.
I'm distracted.
Okay. Don't allow anybody to distract you here. No money, please. Okay, so Jerry, your try was really nice. It shows that you have the idea of it. It's just that you most likely forgot the code. But let me see if there's possibly someone else that knows what should be. There's something called program. Okay, let me just do it here. Thank you. Remember, I said if you want this widespread is like predicting the values. Remember, widespread is literally okay. Since we have trained our model, let's use that model. We feed it with another data set that it has not seen before, and let's see if it will be able to predict accurately what is supposed to be our value for our target. We trained it with 80% of the data. Now we want to predict. Now we want to do a prediction. Let's see if, okay, we have trained it with this thing. Let's now feed it with another set of data that it has not seen. And let's see if it is going to give us, the same values of that one. So when you want to do that, you use the model. Remember, it is the model. Here you were training, so you fit in your X train and your Y train into it. Here you want to predict. So what you do is you call the model name. You do model logreg. Oh, sorry. Underscore logreg. Then I do dot predict. Then what are you going to pass into this place? What do you think should be passed into that place? What do we pass in there?
Text.
Say that again, please.
X test.
Thank you. X test. We want to see. Normally, our X test, if you check your X test, it's supposed to correlate to the values you have in your Y test. But we want to predict now to see if the results we have, if we check it alongside with the Y test, if they're going to be the same or close. That's what we want to do. Do you understand? So let's train that here. So we have our widespread sharp. I want us to see, our white spread is going to be a numpy array. So let's just see the first 5. I'm sure this will be in form of, okay. So look at the form it came out. So there was something I wanted to do in the previous class where I was having an issue. So let me just say comparison, excuse me, pd.data frame. Or let's create a dictionary. We call this one a key value pair. We have our white test. Let our white test be our normal white test that we got when we splitted the data. And then our y thread would now be the values we have here now. This our y thread that we just did. Let's convert that into a data frame. Let's call it comparison table. So we do pd.data frame. We pass data into it. I think that's all we need. Let me confirm. Let's comparison table dot head. I hope this works. Voila. Sharp. You observe that it seems like our predictions are correct. Are you observing what I'm observing? Our white test normally here was 0. And we predicted 0 here. White test here was 1. We still predicted 1. White test here 1, we predicted 1. Here 0, we predicted 0. Here 0, we predicted 0. Let us try it. You can see. Let's see the first 50 that can show up. How dare you give us 100%? Share the model that is extremely accurate. Oh, feels like you have done. Did you observe something here? Feels like we are very extremely accurate. Or who else is seeing what I'm saying? Our predictions and our test values are literally yes, they are the same.
Yes,
I can't see any single error.
They are consistent.
Very consistent. In real life, this may not happen.
Wow.
Yeah, this may not happen. Most of the language models that you see online, ChatGPT and co, they are not 100% accurate. I hope you know. Even this one is not 100% accurate. If you check it, to be like maybe 90, some maybe 98. But this one of the reasons why I know this is not. There are many factors. But trust me, this is a very good model. A very good model. If we get other these things to test it, the tendency that it will also give us something cool is high. But there's something called overfitting. Oh God. I think at this point, excuse me.